Hello.
Happy Saturday, Donald.
Hey, bud. What's up there?
Well, I tell you what I was doing. There was recently through our area and basically the whole middle part of the United States of America went through some storms, and we got to talking about lightning, and then that led us down these huge rabbit holes, way far away from the topics we've been talking about.
Yeah. Kind of a little more on my side of the street.
Yeah, and it was about electricity, and I knew you were an electrician. I'm like, dive deep with me, dude. Tell. I mean, I don't want you to get a textbook out and be a preacher man and saying, I tell you right now, electricity is the greatest thing. But I want you to just help me understand electricity. I know that may be a big tall order, but you know.
Yeah, well, I mean, it is in a lot of ways, but I mean, electricity is just a small part of, energy. Electricity, the stream of free electrons flowing down a wire between 2 points, the potentials between them, let them flow. But it's still a theory. There's no proof that it's real other than, you see the light come on, but, the light coming on is the result of the flow of electricity, causing either resistance or, converting that flow into heat, which creates light, which bleeds over to the visual spectrum. Now, that's just the small part of, energy that we pull off as electricity. Lightning is the same thing. It's a connection between the potential differences of polars, north and south, which, it's magnetic fields and, if you go back to magnets, which of course is how we create electricity. We don't honestly know all the details about it, but, hey, it's useful. We know how to tap it. Lightning, it'd be great if we could harness it, because that's just, a natural phenomenon that taps into it and, can really get it. So if we could find a way to tap into it like nature does, but we already know she's way better than we are at everything,
Well, how do we tap into it? How are we currently tapping into it? I mean, there's multiple ways. I know there's probably nuclear, but what, and in other ways? Tell us ways that we tap into electricity. How do we find it?
A lot of it is, we take, whether it's nuclear or whatever, you're just money changing or transferring and converting from one form of energy to another. The basis of the law of energy or conservation of energy is energy can neither be created nor destroyed. Once you have an energy, it changes. What you are seeing is the results of those changes, but the energy is still all there. You take a log, you catch it on fire. Okay, you started the chain reaction, it starts releasing energy, so you're taking the entire contents of energy built into this log and we are releasing it. Well, it converts to, heat, gases, light, But everything there, if you could grab it all back together, it would equal that log again, as such. So, since it can't do there, we just have to find ways to pull and convert what we can. Lightning is just, it's just too big, too much. There is research into it, type thing. But it's just, we're just too small at the moment to be able to really take any advantage of lightning consistently. I know I've read a few things where, they've had a few looks with sending a streamer up into the air during a storm and it, of course, causing a lightning strike, basically attracting it. But a lot of that, I think, was more for research and that kind of stuff. No real actual practical applications. Fusion is another big one, and now that's one that we've made some huge strides on here recently. In terms of instead of having to use the super cooled magnets, they've been able to, get good use out of some high temperature magnets, type thing that carries the, the Tesla intensity, which is, the intensity of the magnetic field being created to just unheard of levels. Type thing. So there's been some huge strides there, which will go a long way to, if we can ever actually get it to a point that it's safe, get fusion, which is, of course, like the sun. You take heavier elements and you're breaking them down into, lower and lower order elements type thing till you reach a certain point. Our independence on anything foreign would be over, because pretty much if it became like that, the whole world could go to something like that, and we wouldn't need oil or any of the stuff they complain about, So it would be a good thing to come, but a lot of it's still in research stages. But it is interesting.
Well, I mean, and like you said, there's, and I mean, everywhere I go, I see solar fields. I see. We talked about the nuclear, the solar fields. There's, I see a bunch of memes on the internet that are making fun of Tesla cars by having a gasoline generator running behind them.
Yeah.
So I don't even know what that means.
Well, I guess you're just extending your mileage, I'm gonna drag a generator, and once again I'm gonna take, a stored energy source of gasoline, run it through a combustion engine, convert it to another form, turn some magnets, create some electricity to help charge my vehicle. It won't be a lot, but it would constantly give you a little bit of a drip of gas while you're driving and extend your range.
Well, that's what I did with my Toyota Prius I drove for years. I mean, I get 60 miles per gallon, basically. It's basically the same thing. But, I mean, people make fun of it, but that every ounce of that stuff you can say, this is me a little bit waxing poetic, every ounce of oil we can save so we can make plastic, because George Carlin told us that's what we need to make, the earth needs to make us for. So, let's save that to make plastic not burn up. Okay, all right, now back to electricity. So electricity. Now, you went really deep, which I'm glad you did, because I was like, oh wow, like I know we're waxing and nerding out here, but on the basics though, let's just pull back the telescope just a little bit. I want to look at how electricity is made. How do men right now, most of the time, whenever, like in my community where I live, or your community where you live, and they may be the same source, but how do we make electricity there? What produces those little not zeros and ones, but that energy that's pushed down the line? What makes the electricity that I live on right now supplies my house?
Well, it comes from a bunch of sources. I mean, you got hydroelectric, which is, of course, like, for instance, no, we don't have any around here, but these are just general examples. Hydroelectric, you build up pressure. You're using physics, the pressure of the height of a column of water, traveling down through a turbine, and just the falling makes it start turning. It turns, of course, a generator, which is magnets, and coils of wire, which induces the magnetic fields to create electricity. And, that gets sent out, and most of the time it's all pulled together. Basically, most connections are either cross-connected and they kind of share loads. Then you've got nuclear, which is, of course, nuclear material that it heats water to create steam. The steam, of course, is pressurized and run through, again, a turbine, which turns magnets and coils to, again, create electricity. So, it all boils down to, in some shape, form, or fashion, you've got magnets with fields that are perpendicular to each other crossing, and you're knocking those electrons free and creating what we call electricity. That's pretty much the bare bones of it. Now all the hows and whys we do it as far as pulling it off and, and regulate it. Now that's a lot more complex. I'm not an expert on all of that, but
I got you. But hold on. So the poles, the negative poles there. So I got a generator that's got like a negative and a positive on it. But I wonder what creates a negative or a positive, like on my generator? Can you explain that, or is that just too technical?
Well, not really. All it is if it's a permanent magnet type thing, well, all magnets have already naturally orienting fields. You take the geological record.
So you just twisted a magnet around in a circle, like two magnets around a circle, a north pole and a south pole, and it twists, and then whenever you do that, it creates a vortex of sort that electricity flows out, or is that
right? Yeah, you're creating a magnetic field that's either permanent, which is like in a magnet. A magnetic field has a permanent, magnetic field for a magnet. It don't change. Well, then what they'll do is, if in a permanent magnet, they will stick a rotor in the middle that's got coils of wire in it. and they will induce a excitation to it to create a magnetic field that is, 90 degrees out from that one, which will make it pull on one side and, push on the other and make it move. And as it moves, it hits these different connections to make that field constantly, expand and collapse to make that rotation. And that's how a motor works, but you can reverse that the other way with a generator. And it will actually induce it and pull that power off to use as electricity. Now, that's very simplified, but yes, that is basically the case. You're taking two magnetic fields, letting them interact with each other by turning them together.
So, we were talking about this, and a lot of things use that principle to power things, like a train. It uses diesel maybe to power a generator that creates that to run the electric engines or the electric motors, not engines, motors on the train.
Yeah.
That's so weird. So you're just using a power. So electricity is like a power source that generates the spinning of magnets. Is that basically what it is, or no?
Well, electricity is used to create a magnetic field that interacts with each other to make it create linear motion. You're still converting magnetic fields into another form of energy, but we're taking, electrical energy and converting it to mechanical energy. And of course, you lose some in thermal energy. If you got light, of course, it's light energy, all that kind of stuff. So, yeah, it's just the changing of it. But, yes, we use electricity to make them move, but it's the pulsing and changing of the magnetic fields at the right times that create the push-pull that make it move. Just like if you take two magnets and push them together and they get the same pole, they push apart. Flip them around, they suck up. Well, that motor and them constantly are swapping that, so it's always pushing, pulling. And they can control that speed by how intense the magnetic fields interact with each other. The density of it, the flux density is what they call it.
Okay, so that kind of leads into another question I have. You were talking about this the other day in our back channel, and we could charge people to go on our back channel.
They wouldn't enjoy that near as much. Well, they might would, but boy, I'd be red-faced.
No, you pay us what we're doing. All right, but anyway, part of that is there was something you mentioned. I don't know the exact words to describe it, but it was something along the lines of if I it's like electricity is supposed to be there whenever you create this whatever, but it's there quicker. You were talking about how. What were you talking about with that? I didn't know. It captured my imagination, but I couldn't comprehend without a more explanation.
Right. Well, I mean, it was an explanation of, we've got different, of course, it goes back to the theory of electricity. You've got conventional theory, and then you've got, modern theory, and, several theories. And, of course, the theory that I was originally trained on was, electricity travels at the speed of light. Well, that implies it travels down the wire. So forever, there's just been this impression of, I won't say everybody had this impression, but many people in the general field has this impression that, you hook this wire up on the, positive side or negative, and you run it whatever a light second is, length of wire, 178,000 kilometers or miles or something like that. Anyway, and you bring it all the way back around to one side of a switch and then a light bulb and da-da-da-da. And so with that theory, when you close that switch, it should take 1 second for the electricity to go from that side through the wire all the way back to the other side, do its work, and return to reference or ground, whatever you want to call it. But it doesn't do that, So what it actually does is the opposite of that. Well, it just happens. They've done an experiment, and I've seen a couple of YouTube things on it, and I haven't done it, so I won't say it's absolutely true, but seeing is believing within the realm, and they had a whole, just miles and miles of wire. It wasn't a light second work of it, but it was a lot that there should have been a measurable difference, and it wasn't. It was instant. So that says, the electricity is already there. We're just finding ways for the fields to interact in such a way that they pop. They just show up.
Is that a quantum thing, or is that? something not related to quantum.
Well, no, it does lead back to the quantum, because it's actually, that was one of the videos I saw that was the study of the current quantum mechanics, and they were talking about that this is a quantum effect that they're seeing. That they think this is a quantum effect of electricity type thing. So, I mean, I thought it was interesting as well. I mean, it was just new to me. But it was really cool, especially since I'm kind of a geek on a lot of this just theoretical crap.
Well, there was something else. That article you sent to me, I think it was yesterday. It was about another topic we want to talk about with electricity. What was that article? Do you remember what I'm talking about yesterday afternoon? It was... I'm trying to pull it up real quick, because it was like we were trying to prepare for what we were going to do, and maybe that's
I don't remember right offhand anyway.
Okay, no. It was something way periphery. I thought way periphery to electricity until we spoke yesterday, because whenever we were speaking yesterday inside your house, we were sitting there talking about electricity. We were talking about chemical reactions. And we were talking about, well, is the universe electric? Is there any electricity?
I think I remember. We were discussing an article you'd read about the electric universe by another author or person you'd listened to, and I hate to not be able to quote the guy's name, but I didn't get to listen to it. About I think it was the different ways electricity is created more naturally. And it was a contrast about, we tap into how to make electricity, like the magnetic field type thing. And there are other ways that we probably use in a lot of ways, especially storage, like batteries and that kind of stuff. But anyway, in your brain, heck, it's all electrochemical. I mean, everything is an electrical engram. So, I mean, there's a natural thing of, electricity kind of is in the basis of everything. I mean, no matter how it is, and I say electricity, but it's very layman energy. But as we think of electricity, what we measure when you do an EEG or, a heart monitor or any of those kind of things, we are registering that pulse that changes, so that's kind of how we're doing it. But it is an electrical thing. And
the heart and the brain both are measured electrically. I mean, there's electricity in our bodies, obviously, because that's what we're measuring. Right.
Yeah. And that was kind of, I think, what we were discussing, if this is what I remember right, that nature taps into it just so naturally, and, we're artificially trying to do it. And so I think it was just, where we were discussing the generations of electricity and how I was marveling at, hey, look at what goes on here.
Well, and of course, my perspective is that I'm, you and I, we grew up kindergarten on, same schools, grew up together, been friends for 40-something years. So I was sitting there thinking, of course, my cut on it is a little bit more spiritual. Mine was like the light beam thing. Like, we're entities that live under light. And it's powered how? I mean, how is the sun powered? Of course, it's fusion, but this whole thing, the whole earth, just seems very electrical. I mean, the brain, the heart, and I heard this, and it was Sheldrake is his last name. And I can't think of his first name right now, but he was a philosopher from Britain. And I love British philosophers. Those guys that went to, they're actually people. This is a little bit far off. We'll come back to electricity in just a second, but now these guys they go to schools that are very Anglican. These guys, these Alan Watts and Sheldrake. I mean, these guys all go to these very Christian schools, Jesuit type schools, and they come out and they're some of the most atheistic people there are, and actually also some of the most interesting people, because they go in, they delve into everything. They don't just take philosophy and talk about philosophy and talk about a table and banging on it, but they get other theorists like say even Owen Barfield or C.S. Lewis. These guys, they grab everybody and and use all those different sources to make sense of the world. And of course, Sheldrake, he tied philosophy into electricity because the whole thing is just powered. If you look at it, I mean, this light, electricity, it's like this light source that's being converted, through photosynthesis or through whatever other kind of that is. But it's all using the principles of electricity, which we don't even understand. Is the point I was trying to make with the electricity is the fundamental of everything. I mean, if you take away that energy, electricity, and its variations, you don't really have us. That's why I was talking about the light being. That's the philosophical part of it. We're kind of electric at the very thing,
Yeah, I mean, I know one of the comments was made was like, but the electricity is light electricity, and I was like, well, no, not really. I mean, it's a particle and a wave, both at the same time type thing. But it's an interaction of light to us to solar panels. I mean, it causes a chemical or molecular action to create electricity. But at the end of the day, animals and people, and anything that has a synapses firing, there's got to be an electrical spark. So yeah, it boils down to electricity at the very end for existence of us. So like if the sun went out and we could keep the warmth, type thing, and just the sun went out, I mean, that would be it. I mean, we would just die. I mean, we'd turn into a barren rock. I mean, because it's prevalent everywhere. Light is life, period. I mean, everything that has a chance of us living on, it's around a star, which is light. So yeah, I mean, light is life. So we are light beings. So in that philosophical sense, I can agree with that.
Yeah, I didn't want to come to that either because I heard that thing on like the Coast to Coast AM thing a long time ago. I'm like, a light being? I'm not a light being. That sounds like some ghosty stuff. But at the very end, electricity, lightning strike. Is the final. We're the final step. That discharge in our heart that creates this moment. Boom, 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 boom. That right there makes that heartbeat the actual lightning strike. Because a lightning strike and that beat of our heart is the same damn thing. Am I wrong or am I right?
No, it's an electrical discharge created by a potential difference in cells that trigger the muscle to do something. So, and lightning is the potential of 2 points in the sky that there's a path between that it can discharge that potential between it. So, no, they're the same thing, but on vastly different scales.
But it's still the end of the process. And that's what we are. Whenever that last one comes, what happens? Whenever our body no longer transfers electricity, you're in trouble, I'm thinking.
Well, I mean, of course now we've gotten way off of what is electricity to now you're way into philosophy because, I mean, again, now, if you go back from a scientific perspective, which, I personally, I look at is, again, conservation of energy can neither be created nor destroyed. Now, you in your particular package that you are currently inhabiting, type thing, no matter what label you put on it, you are a set of electricity in a storage device that we call the brain, and you operate and you do your stuff. And when that stops, that energy is converted. I mean, it's converted to all kinds of crap. Now you get into the questions, all right, well, does that mean you end? Or does that, since the energy is neither created nor destroyed, or is there that next level, or does it just float around? But it's changed in one shape, form, or fashion, no matter what you want to put on it, where you think you might go, want to go, don't want to go, or anything. It's changed. But the energy is still all there. So, it's not, see, there's my philosophical take on it, and I don't even think about that shit much.
Okay, so let's talk about one. You've already mixed it, and let's go. We got about just a few more minutes. So, when that whenever that energy pattern discharges at lightning or the heartbeat, and we know that there's the conservation of energy. I'm trying to make sense of it. You know, of course, I'm standing right now up under a very beautiful blue sky, and I live near an industrial town. I hear a train going, and so I'm out here in the middle of nature, just right outside of town, and with green in the springtime, and the train purring, and the light shining on me, and photosynthesis occurring all around me. Life and all the things dying out there, all that kind of stuff. I'm trying to take something home from electricity. You've dove deep. I think we've already found a stopping point earlier, but what else can we sum it up with life and electricity? And I mean, how can we tie all that shit together?
Well, I would say just the fact that, like, okay, when we were discussing electricity, or excuse me, lightning, I apologize. You would ask, well, what is it? Well, and my original thing was, it's ionized air to transfer the electrons. It ionizes, creates plasma. But, what we see is just the interaction between it that creates it. But how much else goes on there that, you never see? I mean, you could be having lightning going on right now, which you do in your heart, like we discussed before, and you just don't ever see it. So, I mean, that's where it got back to where lightning and energy and electricity actually powering everything. And I think that's what the connection we were trying to make is, this electricity is everything, but if you want to know what it is, scientifically, man, it's just the interaction of magnetic fields that create a useful thing we tap into.
Hey, that sounds like an interesting place to stop on this deal. At 26:39, hey, Tom, okay, that's an interesting place to stop for sure. So, let's. I tell you what, it was great talking to you, and I'll talk to you soon. But don't hang up.
All right.
Okay, for everybody else out there now.
Do what?
Okay, now I'll start again. All right, now Tommy was wanting us to call him. He said the other day, he says, "I'm cool with Donald, man." Because I told him, I said, we're having a fucking podcast, and we think you should join in. And I sent him a text message a few minutes ago to say that he needed a smoker bowl. But man, I really got to fucking piss.
No, man, hey, get off, and I need to go refill my tea, and I probably need to refill my pipe, and just, kind of get caught up. Jacob's messaged me. I need to catch up with a couple of stuff. So just, 20, 30 minutes, and either call me or message me and just say, hey, are we ready? How about that?
Okay, that sounds good. All right.
All right.